Hello, folks. Our next topic is on something called trigonometry, or as the paper says, it's trigonometric ratios. Um, it's maybe something you heard of. It sounds a little funny and maybe even sounds difficult, but it's actually not too bad. It's one of my favorite um, chapters to teach in geometry. The thing to remember is that everything, it kind of builds off of things that you already know. So even though some of this is going to seem completely new and crazy, it's just a continuation of things that you've kind of been exposed to before. So my leadoff question is, what do we do when the Pythagorean theorem isn't enough and the triangle isn't 45, 45, 90 or 30, 60, 90? So if you recall, in the last couple chapters, we dealt with the Pythagorean theorem, which was just a squared plus b squared equals c squared. And then we had these rules for 45, 45, 90, and 30, 60, 90 degree right triangles that allowed you to solve for different sides, but they required something specific. These require that they only work for triangles that have these specific degrees, and then the Pythagorean theorem only works if you know two sides of a triangle and you want to find the third. But not every right triangle gives you that much information. So that's where this idea of trigonometry comes into play. So the word trigonometry is derived from the ancient Greek, meaning literally measuring triangles. Okay, now the word ratio, we've talked about this before in chapters past. All a ratio is, like if I asked you for an example of a ratio, you might say 1 to 2 or 3 to 7. We compare boys to girls, and we compare, wins to losses. So when we talk about a trig ratio, all we're talking about is that it compares two sides of a triangle. Compares two sides of a triangle. Now, again, these can only be used for right triangles. Right triangles. Now, I can ask you this, so let's look at a side note here for a second. You don't have to write this, just watch what I'm going to draw out here to the side. If I drew this triangle here, and I labeled the sides as 3, 4, and 5, and I said, hey guys, give me a ratio that compares two of the sides of this triangle. Again, in math, we use that in fractional form. So you might say, 3 to 4. That's a ratio. It compares these two parts or these two sides of the triangles. Well, that's one ratio, but there are plenty others, right? You could also say 3 to 5 is another ratio. And then you could also say that 4 to 5 is another ratio. And then guess what? These reciprocals of these are different ratios that could work too, right? Instead of 3 to 4, we could write the ratio as 4 to 3, which is different, right? Those are two separate numbers. So even though they're comparing the same two numbers, they're in a different order, which is important. And then we could do 5 to 3 and then 5 to 4. So the issue here is that if I ask you for a ratio of the comparison of these triangles, there's 6 different options. And that's a lot to handle. So in math, we had to come up with a way for us to talk about these ratios without getting confused. Okay, so that's where these three words are going to come into play: sine, cosine, and tangent. You may have seen these abbreviations on your calculator before. They are abbreviated. Sine is abbreviated as S-I-N. Now, whenever you see S-I-N, you still say sine, okay? Don't say sin. When you hear the word cosine, you can abbreviate that as C-O-S. Again, if you see C-O-S, we say cosine, don't say cos. And then tangent can be abbreviated as T-A-N. These three abbreviations you may see as the buttons on your calculator just above the numbers. So now we're actually going to learn what they are and how to use them. So in other words, we give these 6 angles here names in order for us to talk about, well, okay, which one is which? If I'm looking for a specific ratio, I'm going to have to be a little bit more detailed. So we have the first one's called the sine of A. That's how you pronounce this expression here. Now, in this case, a because it's inside of the trig function like this, since it's a, that means that a is what we call the reference angle. A is the reference angle. It's the point of reference. So right now, the point of reference of you to the board might be straight ahead. The board is directly in front of you. Whereas your point of reference from you to the back wall is completely opposite, right? So it depends, it's kind of like your vantage point. So you'll see what I'm saying. In order for us to set up the sine ratio from angle A, if I'm looking at angle A, so this is our starting point. Pretend we're standing on angle A and we're looking out at the triangle. In order to set up the sine ratio, we're going to compare the side opposite of angle A over the hypotenuse. The side opposite of angle A over the hypotenuse. When we use the word opposite, we mean completely across the triangle. This is opposite. That side does not touch angle A whatsoever. So notice little a is opposite of angle A. So A is the opposite side. The hypotenuse is always the hypotenuse. This will never be anything else, no matter what. And you'll see when I get to switching these why the reference angle is important and how this side A could actually be something different depending on your reference. The hypotenuse in this case is C. So A to C is specifically the ratio that we call the sine of angle A. Next, we have the cosine of angle A. By definition, it compares that the side adjacent to angle A. Now, if you remember, we've used the word adjacent before when we talk about angles. So the word adjacent means next to or touching. So from angle A, we can say, okay, what side is touching angle A? Now, hopefully, you could say, well, angle B, because it says so right here. So you know angle B is touching. But you could also argue that the hypotenuse is touching angle A, right? Isn't this red side right here touching angle A? But the issue is that the hypotenuse can never be anything else. So once you deem a side is the hypotenuse, you cannot use it as an opposite or adjacent side. Okay, so that's reserved for the other two legs of the triangle. So a side adjacent to angle A is going to be side B. And then you compare that to the hypotenuse, which is still side C. Lastly, we have the tangent of angle A. And by definition, it compares the side opposite of angle A to the side adjacent to angle A. So again, opposite we said was A, and then the side adjacent was B. So these are the three main ratios. Next year in Algebra 2, when you look at trig, or in even further in pre-calculus, if you do that, we have other names for the reciprocals. So notice how these are just flipped of each other, and those are called cosecant, secant, and cotangent. But we're not really going to get to those. But notice that that's where we started off with 6, but I only named 3. So that's where the other 3 could come from. But they could also come from something else. So looking here, how the heck are you going to remember opposite and adjacent and tangent and sine and all that kind of good stuff? It's something that we're going to call a mnemonic device. A mnemonic device is just something we use to remember a phrase that we use to remember number or letters, or letters that we can use to remember a phrase. So that phrase, that mnemonic device, is called SOHCAHTOA. You may have heard that mentioned before. It stands for the order of everything. So the first one, so, stands for sine, opposite, hypotenuse. And what it does is this tells you the order that the fraction should be in. Sine is opposite over hypotenuse. So again, if you just remember that this is what the fraction should be, opposite over hypotenuse. You could probably guess that ca is going to be cosine. A stands for adjacent. H still stands for hypotenuse. So if you look back up here at our cosine ratio, that's what these letters stand for, that the cosine is equal to adjacent over hypotenuse. And then lastly, the tangent, we use TOA, and that tangent is equal to opposite over adjacent. Opposite over adjacent. So if you can remember SOHCAHTOA, then you'll be fine in this chapter. SOHCAHTOA. I write that on the top of every paper that I do when I'm dealing with trig. Okay, so let's do an example. This says find the sine, cosine, and tangent of the indicated angle. Write your answer as a fraction and as a decimal rounded to the nearest hundredth. Okay, so we're going to find the sine and the cosine and the tangent of angle S. So the sine of S, you can just write like this, is equal to, now sine is opposite, using this right here, opposite over hypotenuse. So I can put O over H. So again, this reference point of angle S is really important. I want you to imagine yourself standing at angle S and looking at the rest of the triangle. Opposite from angle S is 5, right? It's completely across the triangle. So that's going to be 5 over. The hypotenuse is 13, right? Across from the 90-degree angle. This will never be anything other than the hypotenuse. So 5 over 13 is your answer as a fraction. As a decimal rounded to the nearest hundredth, if you type this in it looks like 73. Let me fix that. There you go. If you divided 5 divided by 13 in your calculator as a decimal to the nearest hundredth, you should get about 0.38. Okay, so there's the sine of angle S. Next, the cosine of angle S using this ratio is A over H, adjacent over hypotenuse. So again, I'm standing on angle S. Adjacent, remember the word adjacent means next to, so you can add that up here in this picture if you want. Adjacent means next to, so next to angle S has to be 12, and the hypotenuse is still 13. Plug that in your calculator to nearest hundredth, you're at about 0.92. And then lastly, the tangent of S, I'm going to move angle R. The tangent of S, using this ratio, is O over A, opposite over adjacent. So opposite of angle S is 5. Over the adjacent, we said was 12. Put that in your calculator, you get about 0.42. So that is the sine and the cosine and the tangent of angle S. Well, here's the deal. I also am asking you about angle R. Angle R changes the reference point. So now I want you to imagine yourself standing at angle R. And then I want you to find the sine and the cosine of tangent from angle R. Look what happens. The sine of R, you still go up here. Sine is still considered opposite over hypotenuse. But when I move positions, the opposite side of that angle is now 12. The hypotenuse, however, is still 13. 12 over 13, you could plug it in your calculator again, although look up here, it's actually the same as in this fraction. So 12 over 13 is approximately 0.92. So the sine of R is 12 over 13. The cosine of R, again, you use adjacent over hypotenuse. But this time, adjacent from angle R, the side touching angle R is 5, and the hypotenuse is 13, which you've already done 5 over 13 over here. As a decimal, it's about 0.38. And then lastly, the tangent of R is still found by comparing opposite over adjacent. But this time, opposite of R is 12. adjacent is 5, and then 12 over 5 is 2.4. 2.4. So you're going to notice a couple of weird but kind of neat things. The sign of S, this number here, is the same as the cosine of R. And then the cosine of S is the same thing as the sine of R. And then these two are reciprocals, right? We just flip the numbers. So that reference angle is so important because it kind of dictates the whole rest of the problem. It dictates what side is opposite and what side is adjacent. The hypotenuse, however, will always be the hypotenuse. Okay, so let's actually do some calculations. This next part here, I want you to write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth using the triangle that I've given you. Okay, so the first one, the sine of J. The sine of J. So pretend you're standing at angle J. How do you find sine? If we use SOHCAHTOA, sine is opposite over hypotenuse. So opposite over hypotenuse. Opposite of angle J, completely across the triangle, not touching it at all, is 60. And the hypotenuse, across from the 90-degree angle, I can label this as H because it'll never be anything else. The hypotenuse is 61. So there's my answer as a fraction. As a decimal, if I divide this in my calculator to the nearest hundredth, I will get about 0.98. Next, what about the cosine of J? The cosine of J. So I'm still at J, that's my reference angle. Let me do a different color. Okay, I'm still at J, but this time cosine, using our mnemonic device, is adjacent over hypotenuse, A over H. The side adjacent to angle J, the side touching angle J, that's not the hypotenuse, is 11. The hypotenuse is 61. 11 over 61 to the nearest hundredth is approximately 0.18. And then the tangent of K. Look at the difference here. I changed up the letter on you. So now my reference angle is different. This time, our vantage point is from angle K. So imagine you're standing at angle K looking at the rest of your triangle. Tangent is still found by doing opposite over adjacent, but our opposite and our adjacent sides have flip-flopped from angle J. This time, opposite of angle K is 11, and adjacent to angle K is 60. Remember the hypotenuse, even though it's 61's touching angle K, it can't be anything else other than the hypotenuse. It's got to be 60. 11 over 60 is also about 0.18. It's really close to the other one when you end up rounding it. Okay, let's try this one. Number 2, write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. So same directions, different triangle. Let's do the cosine of angle A. We're at angle A, so imagine you're standing there. Cosine, go back to your mnemonic device here, SOHCAHTOA. Cosine is the middle one. It's found by doing adjacent over hypotenuse. A over H. So from angle A, adjacent is either 24 or 25. But hopefully you went ahead and labeled 25 as the hypotenuse because it will never be anything else. It's across from the 90-degree angle. So that means adjacent must be 24. The hypotenuse is 25. That as a decimal is 0.96. Tangent of B. So we switch the reference point. B now, imagine standing there. Tangent is still found by doing opposite over adjacent, TOA. Opposite of angle B is 24. Adjacent to angle B is 7. And 24, oops, I wrote 4. (24) over 7 is approximately 3.43. lastly, the sine of angle B. So I'm at the same reference point using angle B. This time, though, the sine is opposite over hypotenuse. So, SOH. Opposite of angle B is 24. The hypotenuse is 25. And I've already done 24 over 25 for the first one, which is 0.96. So hopefully you kind of have the hang of how to find which side is opposite, which side is adjacent, depending on your reference point. And then the hypotenuse is always the hypotenuse no matter what. Okay, number 3 on the back side. It says use the calculator to approximate the following. Now, on your calculator, the first thing you want to do is this little caution here that I have is you want to make sure that your calculator is in degree mode. Degree mode. So if you hit these buttons, so if you do mode, and I'd write this down too, that way you know they're on these notes. You're going to hit the mode button, which is toward the top of your calculator. And then you're going to scroll down and you're going to see 2 words. You're going to see the word degree next to the word radian. You need to make sure the word degree is highlighted. If it's not, go ahead and use the arrow to scroll over to it and hit enter. And then you can hit second quit to get out of that screen. So radians you're going to learn about later in Algebra 2, and then again if you take pre-cal, it's a different unit of measure. We need to make sure that our calculators are in degree mode. Okay, so once you're in degree mode, go ahead and ask Mr. Where. Y'all can pause it here if you're struggling to find out where that is. But make sure they're in degree mode. And then to find these, all you're going to do is literally type them in the calculator. So I should have put the degree symbol here, but all of these are angle measures in degrees. So now we're almost kind of going backwards, or we're, instead of using the ratios given the triangle with a picture, I'm now giving you the angle itself, and I just want you to approximate that decimal using the calculator. So the first one, like the sine of 52 degrees, you literally just hit the sine button and then type in 52, and then you can close parentheses if you want, and then hit enter. And let's go ahead and do to the nearest hundredth here, so 2 decimal places. So the sine of 52 to the nearest hundredth is about 0.79. And then you can type in the cosine of 19 and then hit enter. To the nearest hundredth, you should get approximately 0.95. And then the tangent of 65, you should get about 2.14. 2.14. Okay, so why do we need that? Well, here's the deal. Although all of that was not just, setting up ratios for the heck of it, it was to help us solve for things in a triangle. So again, y'all got really great at using Pythagorean theorem to solve for a missing side, but you could also use trig to solve for a missing side. So here's how it works. If I give you this triangle here, the directions say find the length of BC. So the first thing I want to do is locate side BC is the bottom side. I notice there's no variable, so I'm going to put an X there since that's what I'm trying to find. So we know a few things. We're looking for side X. We know this side AC is 10.2, and we have a 15-degree angle and a 90-degree angle. So the first step to doing this is that we want to choose a reference angle. Right, a point of reference. In the other questions earlier, I basically gave you a reference angle. I told you the cosine of A or the tangent of B, and A and B and J and K, those were all the angles. Now you get to choose what the angle is going to be. Now, basically, the first thing to note is that you cannot use the 90-degree angle for reference. And I want you to think about that for a second. You cannot use the 90-degree angle for reference. We use words like opposite and adjacent, right? And hypotenuse. So if I asked you, just for fun, you don't need to write this down. If I asked you, what is the sine of C in this triangle here? Now, when we talk about sine using SOHCAHTOA, let me write that down again so we have it for reference. SOHCAHTOA. So if we are looking for the sine of C, that means we're setting up opposite over hypotenuse. Opposite over hypotenuse. Now, what side is opposite of angle C? Well, it is the hypotenuse, right? Across from the 90-degree angle. So then we have hypotenuse over the hypotenuse is the hypotenuse, and that just doesn't make sense. And then if I asked you to set up the cosine of C, cosine uses adjacent over hypotenuse. Adjacent means touching or next to. Well, what sides are touching angle C? Well, 10.2 and X are both touching. So how do you choose? You don't. Okay, the moral of the story is that you cannot use the 90-degree angle for a reference angle. It will be one of the two acute angles. I am going to choose 15 degrees just because it is there. It's the given angle. So I'm going to choose 15 degrees. If you wanted, you could subtract 90 and 15 from 180 and get angle A and use that as reference. That would be just as fine. Okay, from my 15-degree angle, I want to ask myself, what do I have? Okay, what do I have? I have 10.2, and I'm looking for X, right? Well, from angle 15, which is angle B, 10.2 is completely opposite. So 10.2 is opposite. X is adjacent to the 15-degree angle. So I've got adjacent and opposite. So then you look over here at your mnemonic device, SOHCAHTOA, and you ask yourself, does sine, cosine, or tangent, so sine, cosine, or tangent, which one of those deals with O and A? And hopefully you say TOA. Right, TOA is opposite over adjacent. So if I'm going to use TOA, then I can set up an equation. Okay, then I can say that the tangent of, we always put our reference angle inside, right? So the tangent of 15 is equal to, you put opposite over adjacent. So opposite was 10.2. Adjacent is X. Okay, hopefully you're with me so far. The next thing to do is solve for X. It's to get X by itself. So what we're going to do is, notice I have, what I can do is I can put my left number over 1. And now I have a proportion. Now I have a fraction equal to a fraction, which means I can go ahead and cross multiply. So let's do that. If I cross multiply, then I get the tangent of 15 times X is equal to 1 times 10.2, which is just 10.2. Now, if I'm trying to get X by itself, let's go off to the side here for a second. Don't write this, just kind of answer this question for me. If I had 50X is equal to 100, and I wanted to get X alone, every single one of you in this room would tell me that I would need to divide both sides by 50 to get X alone, right? Because it's being multiplied by 50. So in order for me to get X alone, I'm going to divide by 50 so that I now get X equals 2. Okay, you use the same logic in this next step. If I'm trying to get X alone, you need to just remember that the tangent of 15, even though it looks like a word, the tangent of 15 is actually just a number. So if I divide this side by tangent of 15, it cancels. And then what I do to one side, I need to do to the other. So now I have tangent of 15. So what this means is in your calculator, so all we have left on the left side is X equals, in your calculator you're going to type in 10.2 over the tangent of 15. And I ask you to round to the nearest hundredth, so 2 places beyond the decimal. And if you do that, you're going to get that it's approximately 38.07. Notice I give you some dimensions there, so that's going to be in feet. 38.07 feet. Okay, let's do another. Number 5. What is the length of QR? So again, as I look at my picture, the first thing I want to do is locate QR. It's right here. And there's no variable there, so I'll put an X, or you can put any other letter you want there. Okay. First thing to do is choose a reference angle. So my reference angle, again, you can never choose 90. So I'm going to choose 63 just because it's there. Okay, it's the angle that they give us. From 63, let's see, other information that I know on my picture is, I know 12.9, it's given to us. And we're looking for X. So from my 63 degree angle, if I were standing at this angle, what is 12.9? Using words like hypotenuse, adjacent, and opposite. Well, hopefully you said that 12.9 is the hypotenuse of that triangle. Don't get tricked by putting adjacent. 12.9 is the hypotenuse. X is completely across the triangle, which means it is opposite. So you have H and O. If you look at your SOHCAHTOA mnemonic device, you look for which one, sine, cosine, or tangent, has H and O. Well, it's this one here. S-O-H, the SO. S-O-H. So it's going to be the sine function. Okay, that's how you know which one to pick. So now let's set up our equation. Sine equals opposite over hypotenuse. So that means the sine of our angle is 63 is equal to, this says put opposite over hypotenuse. Well, opposite is x, so it's going to be x over, the hypotenuse is 12.9. So you use this part of the mnemonic device to help you set up the equation. After you set up the equation, you can put the left side over 1. You can cross multiply because you have a fraction equal to a fraction. If you do that, then you have the sine of 63 cross multiplied times 12.9. And that's equal to 1 times x, which is x. Well, the goal is to solve for x. It's to try to get x by itself. Well, notice after 1 cross multiplication, x is already by itself. So all you need to do is type this into your calculator. The sine of 63, make sure you close parentheses, and then put times 12.9. If you do that, you're going to get that x to the nearest hundredth is approximately 11.49 centimeters. Or they ask you technically for QR, which you called x earlier. So if you want to be technical, you could put QR as approximately 11.49 centimeters. Last question, number 6. Find the length of FD. Again, locate FD. If there's not a variable, put one. First thing we do every single time when we're trying to solve is choose a reference angle. I'm going to choose 39 because it's the angle that's given to me. And then I'm going to list my information. I have an x value that I'm trying to find, and I have a side length of 20. From my angle of reference, side x is the hypotenuse because it's across from the 90-degree angle, and the 20 is adjacent to 39. So when I list this information, guys, you're always going to use the words adjacent, hypotenuse, and opposite to figure out where that side is in reference to the angle. And then if you look at your mnemonic device, SOHCAHTOA, you need to ask yourself which one has H and A. Well, S has O and H. C, cosine, has A and H. That's what you're looking for. So that's how we know we're going to use the cosine ratio, CAH. So cosine is adjacent over hypotenuse. So we're going to set up our equation. Cosine of 39 is equal to adjacent. We said the side adjacent was 20 over the hypotenuse is x. So that's how you set it up. Last thing to do is to solve. If I'm trying to get x by itself, I'm going to put the left side over 1, cross multiply. When I cross multiply, I get the cosine of 39, cross down multiplied times x, is equal to the other multiplication, 1 times 20, which is just 20. Now, after multiplying like that, x is not by itself. So my work isn't done yet. In the question before, after 1 cross multiplication, because of where x was, I just multiplied and I'm done. But here, x is still stuck. So in order for me to get x by itself, right now it's being multiplied by the cosine of 39. So I need to divide by the cosine of 39 in order to isolate it or get it by itself. That means we have remaining on the left side, x is equal to 20 divided by the cosine of 39, and that's what you type into your calculator. To the nearest hundredth, you should get 25.74. So your final answer, the length of FD, is approximately 25.74 meters. So that's how we can use trig to A, just set up ratios that compare the side lengths of triangles, or B, like the last 3 examples we did, was actually set up those ratios and then solve them to figure out missing side lengths of your triangle.